meetup. And then we welcome Lennart instead to, on our 24-hour notice, get going with another talk. So a little bit about Cloud Native Nordics, this community, and so on and so forth. So we are a set of meetup groups in, well, 3 places in Finland. I highly recommend you to check the other ones out as well. If not in person, then you can always watch the stream. It's all in the Cloud Native Nordics meetup group. And then we also do collaboration with a lot of other meetup groups in the Nordics. Naturally, we're now 1,500 something in all of Finland, and 100 and almost 70. Hope we'll break that in a couple of days. Maybe 200 even for the Turku one. In short, code of conduct, be nice, respectful to everybody. And there's a lot of social places you can join the community in. Highly recommend the CNCF, the Cloud Native Computing Foundation Slack, Kubernetes Slack, these kind of Cloud Native Nordic Slack. Well, this is then on the Cloud Native Nordics YouTube channel. There's all kinds of other things as well. We would very much like to get future places to host a meetup at for all of the meetup groups, but, well, for you, maybe specifically Turku. So if you have a space like this that would be good to host a meetup at, then let me, Sami, Erik, Anton know about this. And also, we'd be very happy to see you share your stories about these things. It all kind of helps the community grow and nurture. And you can contact us, any of us, or fill in that link. So a little context: what is Cloud Native for those that maybe haven't been at this meetup before? Is there any first-timers, by the way, at this meetup? Okay, nice, welcome. Perfect. So what is CNCF? CNCF is a non-profit that is working under the Linux Foundation that brings together all of the kind of, it's a vendor-neutral umbrella for all of the Cloud Native kind of projects. There's a lot of Cloud Native projects available. We'll see a couple of pictures on the slides soon. But in short, it allows kind of for a vendor-neutral place to have all of the kind of open source code to be stored. And then CNCF also helps with lots of other kind of things like running events and stuff. So, well, there's kind of a couple of different parts. There's a lot of members. Then there's kind of a technical oversight committee that checks which projects to include and kind of into the foundation. And then a lot of end users as well that kind of actually use the technology. So some develop it, some check that it's good, and some actually use it. CNCF projects are classified in 3 kind of brackets. Well, there's the sandbox. Those are for new projects that kind of are very novel in their ways of doing things, or yet a little bit unproven still. Maybe has contributions from only one company and maybe not used in production yet. But then the incubating projects are used by, it has very solid core, used by multiple companies in production, hopefully has multiple contributing companies and stuff, but still hasn't maybe crossed the chasm of where like everyone is using it, right? Which is then for the graduated projects when it's super stable, like lots of tests, security audit done, all of these kind of rock solid. The technical criteria for getting to the graduate estate is extremely high. And here are some of the graduated projects. From some of them you might recognize, like Kubernetes, and we have Prometheus is also another very popular project, Helm, Envoy, Containerd, maybe someone has done Flux or GitOps, then Flux and Argo, running MySQL in a kind of highly replicated way with this, you can do that, or running Ceph storage with Rook, or Jaeger for tracing and kind of different telemetry stuff, etc., etc. There's a lot of them. Then there's even more of them in the incubating phase. Here I can't kind of enumerate them all, but something that people might know is Keycloak actually joined quite recently. Then Istio, if someone has done service mesh, there's also the Linkerd for service mesh, and Cilium, now actually Cilium graduated, I think. This is always like, it's impossible to keep up with this. But Backstage, if you do platform engineering for your company. Lots and lots of stuff. And then we come to the sandbox projects, the kind of lowest tier, or where we have some really good projects as well. And let's see. So correct me, what is Metal Tree? There. Yeah, I was looking for it. Yeah, so lots of great stuff here as well. Lots of things to do, high kind of criteria to get to but still the good thing about being in CNCF, although in the kind of first tier is that like it provides an opportunity for multiple companies to kind of come together and contribute to the same place. There's a problem otherwise if one company only owns the code, then they can relicense the project and do some bad stuff with it. That it's kind of a safer bet to put it in an organization like this. So CNCF does a lot of things. They collect this landscape. They have some tech radars, like from end users. They do certifications, lots of events. So certifications, I recommend if you want to kind of, there's a massive online course, a MOOC, available for free, but then you can also certify yourself and kind of get trainings and all kind of stuff. Through Linux Foundation like this, good content in there. If you are a company that provides Kubernetes to other people or kind of want to show your expertise, then you can also apply for the service provider. There's also a training partner where essentially you need to have X amount of people to have passed the exam. If you provide some kind of Kubernetes solution, then you can show that it's actually working as it should be through the conformance program. All these kind of meta things CNCF help with. And then there's a lot of things with the community. So like, well, now for the Finnish meetup, we haven't needed the CNCF funding in a while, but actually the last time we used the CNCF funding was to get to Ericsson with the bus from Helsinki. So they help with these meetups if needed. And there's all kinds of mentorship programs, live streams like every single day about some projects. There's community days. We had one with the Cloud Native Nordics community in a KCD, Kubernetes Community Days in Denmark 2 weeks ago or so, which are like smaller conferences, like one-day conferences. And then there's a big KubeCon, Cloud Native Con that have like 10,000 people or something like that in Amsterdam, like in the beginning of the year. And there was one in Chicago recently, a couple of weeks ago as well. So talking about that, we have also another KubeCon coming up. There's always one in Europe in the spring, then China, kind of early fall or summer, and then in the end of the year, like fall, early winter, there's a North America one. So yeah, Paris is coming up. I highly recommend to get the tickets. Let's see. You have still 5 hours to get the discounted price. If you want to get the early bird ticket. So I highly recommend. I can actually share a discount code, which I also got, which is 15% off, or was it 10, something like that, for you to even get the early bird ticket. So that's good. But yeah, book your tickets in advance. They sold out last year, and the pressure on the hotels will be rough. But it's an amazing conference. Lots of good ways to to interact with the community and kind of get to know the maintainers and watch talks. If you miss it though, you can always watch the videos, all of the conference videos online on YouTube afterward for totally free. So that's also another way. So yes, that's essentially it for the introduction. Is there anything else we should say here? I don't think we need to do that. Any questions at this point? Perfect. Then let's see if Anton is ready. Yeah. Okay. That sounds good. A couple of commands. Yeah. Yeah. I can relate. Do you want the clicker?
No, I'm gonna use the computer.
Do you want this one?
That one I probably need, yeah.
Yes.
Yeah, let's see here. Linux, so now we need to mirror desktops here, but
Most exciting part of it.
Well, I can steal the space for a moment. We will have pizza here later on, so if you're hungry, stay hungry.
we should present, but where is the present?
In the right corner.
Oh yeah, nice. Helps if you look at the correct thing. Yes, hello everyone. My name is Anton. I used to be like more active in organizing these events, but now I have this thing called school and work, so I haven't been able to play around much. But this is something I've done. I currently work at Walkbase, and one thing we do, and that we do a lot, is we do a lot of Postgres, and it has traditionally, or like at least in our company, we have always had these. Like we started with bare metal, then we went to VMs. We're still. Oh yeah, sorry. I looked at the screen, but I didn't figure it out. Like somehow mirrored. Yeah, like we started out on bare metal many years ago. Then we went to VMs, and we still have this like Ansible stack that we use. And I personally, like I don't hate Ansible, but we're not good friends either. Like it's a bit finicky. So I've actually tried to look for solutions to or modernize the stack. And during the last year or so, I found this thing that I'm going to present today. And of course, it involves Kubernetes. So a bit about me. I currently work as a DevOps sysadmin guy at Walkbase here in Kupittaa. Walkbase does like indoor positioning, market analytics, that type of stuff. As for computers, first home computer was a Windows 98 machine. But the oldest computer I've ever actively used was a ZX Spectrum, like we're talking C cassette tapes and funky keyboards. And for the longest times I used to be like a Windows guy, but nowadays I use Linux everywhere. Kubernetes we started using or like testing out at version 1.9, and we have stuck with it ever since. In my spare time, I play a lot of racket sports. I also picked up this new thing this year, like I go winter bathing. Really cool, highly recommend. And then if I have time, I brew, and then I have this home lab setup running at home that I also like to play around with. I don't use social media like at all, but if you want to find me, I'm Lennart on GitHub. So, to the elephant in the room, should you really run stateful workloads in Kubernetes? This is one of those things that people are really afraid to do, but in my experience, like just go for it and learn. You have to be a bit careful, but in general, like I think it's fine, and especially like now during the recent like 2 or 3 years. It's actually like really fine. Like with that out of the way, I'm going to talk a bit about what an operator is. And for people who haven't used Kubernetes, Kubernetes it's not an operating system. It's more like a platform, and a platform for building platforms. Yes, and the nice thing with Kubernetes is that you have this API, and this API is super extendable. And if you want to extend this API, you can. There are lots of different, like you can have these like admission webhooks and so forth, and then you can also run these controllers. And how the controllers work is that you define a new custom resource, like something that isn't native to the Kubernetes, like that doesn't come out of the box. So for example, I can define a car, and then I specify like, okay, this is the values that a car can have, and then in the background I have this controller that checks the API server and like pulls and checks if there are any new cars, and if there are any cars, how do we run the cars and so forth. So you have custom resources, and you have an operator, and the operator, like it's a fancy reconcile loop pretty much. It ensures that the state eventually converges to the defined state in the custom resource. And I think is it the operator framework by Red Hat or someone, but there is like this different tiers of what an operator can do. But in general, what they do is like they deploy the stuff you want, then it helps you with updating and configuring the stuff. What about monitoring? Usually these operators, they help you with that as well, alerting, all that type of stuff. And then like in Postgres and these other operators that we run, backups usually come out of the box. And then when you have run your stuff for a year, what about upgrades? Or like how can you easily upgrade 50 instances of something? Operators help a lot with that as well. So quick summary, what an operator helps you do is to keep your infrastructure like in control. You have someone else there, like consistently watching and maintaining the state. Then they also help you scale stuff. I have a Postgres database that is running out of space. I just tell the operator to give the stuff more space, and it will handle it. It also scales the monitoring capabilities. Like if you run 50 clusters, instead of deploying the same YAML everywhere, you just change your CRD or custom resource, and the operator will handle the rest. And then this last thing that I added here, knowledge scalability. Like if you deploy a complex thing out of the box, hack it into the cluster, it can be quite finicky. Like you can have lots of YAML, but then when you have everything defined in a custom resource, when someone else who hasn't worked with this for 4 weeks looks at the resource, it's easier for them to get an overview of, okay, this is what Anton wanted, and this is why he wrote this comment, instead of like trailing through YAML. Like YAML isn't the nicest way to define things.
Or traditional look through the bash history.
Oh yeah, bash history. I actually do that. I do that. So what about PostgreSQL? Has anyone here not heard about PostgreSQL before? Okay, yeah, so kind of familiar to everyone. Just out of curiosity, I checked the Stack Overflow developer survey, and I'm not sure when, but at least nowadays it's the most popular database, at least in professional use. And I think also if you press like all respondents, it's also up there at the top. So it's a relational database. The good thing with Postgres is that there are lots of buttons to press. That's also a bad thing, but there are tools there that get you gets you quite or like there are tools there to help you configure and maintain the thing. One thing that we use internally is called pgtune. It pretty much checks like what type of machine is this Postgres database running on, what are some sane defaults, because like out of the box it isn't optimized the configuration, and there is lots of performance to be had by like fixing the configuration. Then it supports replication. So like you have one main instance, and then you have replicas. And then you can do like this failover. So if the master is unhealthy, is having a doozy of a day, you just tell Postgres to now promote this other machine in some other availability zone to handle all the traffic, and Postgres will handle it. Then when you have your cluster, you of course need users, you need all the migrations, all that type of stuff. There isn't any like good built-in thing in Postgres, I would say, but there are lots of migration tools, and then, for example, this operator that I will present today also handles this. Personally at Walkbase, we have this separate tool and separate repository, but we deploy all the migration stuff through Kubernetes jobs, and then we use HashiCorp Vault for managing the users. Then when it comes to backups, there is this like tool that ships with Postgres called PG Dump, that pretty much it can dump tables, it can dump full databases, whatnot. Works great for smaller databases, but then as soon as you go over some certain limit, like let's say a terabyte, PG Dump starts to take up a lot of time. And then there are actually like better suited backup tools like Backrest, Barman, and then PG Base backup. The good thing with, for example, Barman is that you take an initial like backup, full snapshot of the database, and then you continuously archive WAL files, so you can always like return to a state at a specific point. And this is needed because like the backups can take over a day to run, and then you have the next daily backup running, and bad things will happen. So all in all, if you like small databases that you run on some small node somewhere, fine to do that manually, but as soon as you get over a certain size or amount of databases, you need some automation. And yeah, as I said, I've actively investigated different solutions. There is, for example, Zalando has one Postgres operator, then there is the CrunchyDB operator. I'm actually going to go to PostgreSQL in a few weeks, and there was a workshop with the third operator that I hadn't heard about. But yeah, we have run the Zalando thing. It's a bit finicky, so I looked for other solutions, and then I found Cloud Native PG. And this is actually a fairly new project, or at least I haven't stumbled upon it before. And then turns out that they have a quite active community, so I thought I would give it a shot. This is how you set up your cluster to get the thing going. It's pretty much just Helm install or put it into your favorite GitHub solution, and it will install the stuff. Like it's a single deployment that runs in your cluster and watches for Postgres clusters and other stuff. It also ships with this really neat plugin. For those who don't know, there is this package manager or package. I'm not sure if you can call it a package manager, but it's a thing that installs packages, extends your kubectl. So I'm going to call it a package manager. Its name is Crew. I think it's a play on the name Brew from macOS. And this is actually a thing that has taken off. You can find a lot of plugins. So if you haven't done it already, you can go to either Artifact Hub, or then there is this GitHub repository with all the stuff that you can install. And there is quite a lot of neat stuff there, like that helps your day-to-day stuff. But yeah, we have the operator installed, and now we have to do the actual important decisions. So first thing we have to think about is what type of nodes. Like, will this database, will it need beefy bare metal nodes? Can we handle with like small VMs somewhere? Do we want share nodes, or do we want to taint the nodes to hinder other workloads for running on the thing? All of this is like decisions that you should plan it like ahead of time, because not doing that, you can usually fix stuff, but it's easier not to fix and just do correct from the beginning, if you get my gist. What type of storage should we use? You can run Postgres using network attached storage. What I've read and what we have also experienced is as soon as you add latency, to the storage layer, your Postgres performance suffers. And I think that holds true for all types of databases. So what I would recommend is to use either local storage on the node. So you provision, you get a bare metal node, and then you tell Postgres to use this local path. And what Kubernetes will then do is that it will always schedule the same pod on that same node. And then you get like the full bare metal performance, but all the nice features you can get through the Kubernetes API. Another thing is that if you don't use bare metal storage, there is this thing called CSI, like Container Storage Interface. There are lots of CSI providers, and one of the features you usually see through the CSI provider is like replication. So when the data gets written to one node, it actually gets instantly replicated to another node, and this adds latency. So if you're gonna do a multi-node Postgres setup, disable or don't use the storage provided replication, because it's kind of redundant as well, since the Postgres will ensure the data gets replicated. So your 2 gigs of Postgres tables will actually be like 4 gigs or more on disk, and it will be slower. So write once and actually make sure you do that. Then Postgres, there are some settings. Some settings you can change on the fly. Others will require a database reboot. So like do a small test cluster, run pgtune, get the initial settings, and then you apply those to your actual soon to be real workload. Like if you don't get all the settings right, if you want to change something in the future, that's possible. So let's design a demo cluster. In my case, I wanted some instances. I thought 3 was a nice number, so let's do 3. I've written that I need 20 gigs of storage, but I think my demo setup has 30. What this operator lets you do is to split storage and WAL files to different volumes. So if you need faster disks for WAL files, you can actually do that. So you can pretty much prioritize performance in your storage. Then we want automated backups, and we want MTLS, so encrypted traffic between the nodes and between the user and the node. So what does that look like in reality? Like this. Here we can see. Did it have a laser? No. Ooh, yes. Yeah. So here we can see this is like this up here. It's the API, and then what type of custom resource we are creating. And this is actually this. This doesn't exist in a normal Kubernetes cluster, but it comes when you install the operator. It installs the custom resource definition as well. And then we give the custom resource a name. In this case, demo cluster. And then we specify that we want 3 instances. Since this will be running on my home cluster and I have a lot of experimental stuff there, I chose the most stable thing, which is my Longhorn instance, to provide the storage. If you have a default storage class in your cluster and that's fine to use, then it's enough to just write storage 20 gigs and WAL storage 5 gigs. CSI provider for Kubernetes. It's based on iSCSI, and it works fairly well for this. If you have a home cluster, I highly recommend checking it out. It's made by a rancher and it's incubating, yeah, it's kind of stable, and yeah, I've run it with a few Raspberry Pis and dosed my home Wi-Fi with the thing, but yeah. So let's go live, and this is probably really small now. Is this better? And then we're gonna do like so, and we're gonna do like so. So here is the YAML I'm gonna apply. This is identical to what the stuff we saw before, but here I've actually also added the backup part. And there are a few different types of backups. You can do snapshots as well, but but since when I first tried this, I did bare metal storage. I chose to use like Barman that they have built in, and then I have this Minio instance running in this cluster as well. Minio, for the uninformed, is like this open source S3 clone, and it works quite well in smaller clusters, and if you want to run it in a bigger cluster, they also have like enterprise support and stuff. So yeah, I give it a Minio instance, and then I define like I want to retain my backup, or the retention policy should be 7 days. And yep.
Why is it called Barman object storage?
Barman object storage. So I think it's because the backup solution it will use in the background is called Barman, and object store is because it uses S3. But yeah, it's a good question. I actually don't know. I haven't thought about that actually. And then it's the same stuff.
Is it kind of incremented backups, or doing a full backup?
It does an initial full backup, and then after that it will do like while streaming. Björn, you have to keep me honest here.
You're correct.
Yeah.
Archive WAL files. So any backup keeps WAL files for 7 days back.
Yeah. What's super neat is since it keeps the WAL files as well. Like if you did something 15 minutes ago, you can actually restore to 20 minutes ago, or you can check like exactly which transaction was the bad one, and then you can restore to just before that transaction. But yeah, as we can see, oh yeah, by the way, I use a lot of aliases. So if there are any commands I run that are a bit like iffy, just say so, and I will explain what it does. Everything that is core is like RK is like kubectl. So yeah, in this namespace, we run the demo instance, and then we have then we have a separate namespace where the operator runs. And what happens if we? How do we do this easily? So here on the right side, we will see all the pod updates that happens in the namespace. And if we now apply the cluster YAML, a cluster object is created in Kubernetes, and here on the right side we see that something starts happening in the background. It has created this new pod here. This pod pretty much it spawns, it gets the storage attached, and it runs initdb, creates like a new database, and like gets up and running. If you want, you can also put like initial migrations and stuff in the CRD, and those will be applied straight out of the box. You can also configure stuff that like initial database name and such, everything in the CRD. We see that there is here's the first pod, and then when the first pod is up and running, we get a second pod created. This pod will actually it will get created, and then it will connect through MTLS to the first pod and start replicating stuff. In a bit we will see a third pod joining as well, but in the meanwhile I can do. This is a CMPG kubectl plugin, and it has one status command, and we can do like this. Let's see, can we see? Actually going to make it a bit smaller, I think. You can still see it. Yeah. So pretty much when you do status, you get the full cluster status. We get the name. We see the current state. Like this line is pretty nice to check. Like it tells you if you have done goofed. Then it's like how many instances and where the cluster is at. Another neat thing is that you see all the replication slots. So you can see like which replicas are lagging behind the master, like which ones are healthy, which ones are failing. Yeah. Like for these are now like hot replicas. So I can show it in a bit, but you can with Postgres you can do all write workloads or all workloads that need write access target the primary instance, and then if you have some heavy select or something, you can target that on a replica, and then like thus offload stuff on the replicas. The only issue is that if you do a select on a large table, and something gets written to the same table while the select is running on the replica, what will happen is that like the replica will start to lag behind and buffer up val files, and that's why it's nice that you have like separate val drives, so you can like go in and give it some more breathing space if needed. So yeah, this was status that I talked for a while, and if we run the thing again, we can see that it has updated. Now we actually have two nodes that are both like streaming, trying to get up and synced. We get down here, we see the instance status. The primary is up and running, and like database is quite small. What it also did in the background is that it created a few services. All these demo cluster services are like targeting the pods for this cluster. And we check the secrets, we can see that it has created a new CA certificates for both server and replication. And then you have this demo cluster app. This is like the secret that contains the initial user. You can do like this, and we can see like you have user, DB name, password.
I hope it's not online.
No. This thing is in Raunistol as well. So if it would be online, it would be really hard to find. Another neat thing you can do with CMPG, let's do, like these migrations, I could have applied them through the CRD, but I chose to do it this way so we can enjoy the features of the operator. So I want to connect to the database, but I don't want to fiddle with port forwarding, or I don't want to expose the database anywhere. So what I can do is I can use the plugin. Then I do PSQL and the cluster name. And this does support forward in the background, uses the credentials in the cluster, gets me in. So what we see here is a default Postgres prompt. We connect to the database, and then we create a table called tools and insert a bunch of neat tools. Do like this so we don't fill up the screen. So like database is operational, and now when we have the database there, we can check has it replicated. I was too slow. It has replicated. But yeah, as you can see, the continuous backup isn't running yet, but like all the replicas are up to sync or up to date. So how to get continuous backups running? Normally, you maybe create a cron job or something. Maybe you have a guy with a fancy calendar. Many ways to do these types of things, but in this world, a neat way is to use a scheduled backup. This is pretty much like all you can fill in. You give it a schedule. The immediate thing here makes it so the backup triggers like it does the initial backup immediately. It doesn't wait for the thing to actually trigger. And then of course you define like what cluster to back up. So let's do apply the backups. This is also a custom resource. If I want to see what's the status, I can do go get backups. Oh, someone has backed up this thing before. Yeah, so This wasn't unexpected. Maybe it's running. We can do a CMPG thing. Let's do like this. Now we're gonna go into Minio and clean this out as well, just in case. So this is the S3 thing that I'm running in the background, but we're gonna nuke it like so. No. I do this daily and I even get paid. Okay, so let's see. Do we have? Yeah, now it's clean again. So let's do this, and then we do. Now, this is what I always wanted to see. So now what happened is that I applied the scheduled backups. I had the immediate flag there. So now it created a new custom resource called backup, and that thing gets picked up by the operator. The operator backs up the cluster, uploads it to Minio, and all my data is safe. Let's see if this thing it's still running. It's usually really quick with these small things. It might be doing something. Oh, here we have the backup. We have the vals. Then it will have the base backup above this. If we want to get the status, we can do. Yeah, but you need to do like this. The taxi there, that's for colors. Do we have? Yeah, so now we can see that we have continuous backup running. First point of recoverability, how far back can we go? It's actually like this date. And then after that, we can rely on val files to replay up to a certain transaction or whatever we want to do. Day-to-day operations, for example, you need to change a disk on a node or something. If I want to promote a node, it's promote cluster node. So we do co-promote. So I specify what cluster, and then now number 1 is the primary. Let's do number 2. And now if we do the watch thing again, we will see that switchover is in progress, and the operator will take care of the promotion happening. How we do this in Ansible is that we have like a specific role that creates this file on disk that triggers this same operation. It works, but I think this is a bit neater. And just like that, now we have the cluster in a healthy state. Other neat things that you can do with this operator, for example, for development purposes, you have 50 developers, everyone needs their own database. How to keep those databases up sync, like how to keep them current. I've seen many solutions to this, but this is one neat way to do it with this operator. What we can do is we can create like this specific backup for a developer. And let's apply it right away. Like so, and then we'll take a look at it. This is pretty much a this is pretty much a backup object. kind of bare bones. You just need to specify the cluster name and then create it in the correct namespace, and the operator will pick it up and do its thing. Let's see if we have the backups there. Okay, it's already completed. I'm too slow of a typer apparently. Need more data. So now we have a backup called developer backup. What can we do with that thing? We can create a developer cluster. And what's neat here is that this is like a separate cluster instance. So the developer can run their own migrations, their own backups, roll back, like they do something funky. Instead of spending an hour to create a new cluster, they can just use backups to roll back in time. Difference between this and the other cluster is here we run one instance, and then we bootstrap it from a backup. And this one you can also you can have your production database with a shit ton of resources, and then you have the smaller database for the developer. So this you can scale it separately. So let's see if we can get the developer cluster up and running. So now what we see is that instead of just creating the initdb thing, it creates this. It starts with this recovery pod instead. So instead of bootstrapping the database from scratch, it will. That doesn't look nice. Well, there is something going on there, and I'm not 100% sure. But this will get resolved eventually. Sometimes it takes a while, and then the correct WAL files get synced. But yeah, I should have sacrificed a USB drive or something. Demo gods aren't happy. Well, what I wanted to show is that you can take a backup and deploy a new cluster, but not today. We do like this. It's always a bit. I hate those recording tools. So I always do it live, but then I always kind of regret it. But then it takes a few weeks, and then I do it again, and then I realize I hate the recording tools and such. Stuff I didn't show. The operator also has support for connection pooling. So you can have this thing called PG Bouncer ahead of Postgres. And what it does is it's pretty much it handles the open connections you have to the database. So if all your clients connect to the PG Bouncer will take care to not keep too many idle connections up and such. The point-in-time recovery, that's super nice. And I didn't show that, but that pretty much enables you to roll up to a specific transaction. Then what you can do, Postgres comes with a lot of neat plugins. PostGIS is one popular one. TimescaleDB is another. If you want custom plugins and you have immutable stuff like container images, what you can do is they have this neat little list. This is what a CNPG Postgres database needs, and then you can take that list and you can take your own image, install whatever you want into the image, and then you just specify instead of using the official image, use this thing instead. And if your thing needs some SQL to be run, you can do that as you provision the cluster. You just specify run these SQL things, and everything will get set up. I don't run any monitoring on my home cluster, but this is what the monitoring dashboards look like. Kinda detailed, and as you can see, that it comes with alerting as well. So you have built-in alerts, and then you can add your own stuff. Really, really neat, in my opinion. So evaluation. I think the documentation is nice, but with all documentation, it also sucks a bit. I think it's quite easy to spin up a bunch of clusters and keeping the clusters in sync. What's super neat is that when you have these custom resources, you can keep those in your GitHub's deployment pipeline, and then they don't change in the cluster pretty much. So super GitHub's friendly. a neat thing that this project does, Kubernetes used to do it, I'm not sure they do it anymore, but they have this thing called office hours. So like once a month, they do it still. Or yeah, it's super neat because like once a month or so, they post in their Slack channel that, hey, we have office hours. Then you just join a Zoom call or similar, and then you can chat with developers and other users, tell them about your pain points and your solutions and so forth. They have a quite large Slack channel, so if you need help or someone to talk to, you can go there. They will help you with anything CMPG related. And the GitHub repository and organization is actually pretty robust, well managed and so forth. As you can see, sometimes stuff break, and then we had this, a few weeks ago, we had this internal discussion with Dumas and VP, and we pondered about like how to do major upgrades, how to go from Postgres 15 to 16, and there isn't much in documentation about this at all, but while doing this presentation, I realized that they actually have they have 4 blog posts on how to do it, but it's like 4 thesis length blog posts, so it's like with all database upgrades, it's a bit sketchy, but this one, like it was well documented, but yeah, I would probably test it a few times before actually doing this on a production cluster. And yeah, we're probably going to stay on with the Ansible stack for a while at least, but for smaller databases, we're actually going to start use this, I think. And before questions, I'm going to see if we got the, yeah, so this is what happens when you tab away, it actually fixes itself. So now we have the developer cluster running. If I would connect there, it would have the same data. Yeah, I'm not sure why it does that, but yeah, if I find out, I will open an issue and open a PR, and that's that. So all slides and the YAML is available there in my GitHub or using the QR code. Any questions? Thanks for listening to me.
Thanks.
Thank you. Yes, maybe we have a food break at this point. Probably we pause the streaming for the moment.
Yeah,
so
we can put the...
Yes. So we'll be back after.
Table, which one?
Yeah, and this one. Okay, let's do that.
No, it's off. No?
Start streaming.
Oh, it's this one.
I'll book this one.
are we live? Yes. Maybe. All right, maybe better like this. Yeah, great. All right, we continue. Yeah, that was. I think he has the remote. Yeah. Okay, so as you probably heard already, this is a bit not so much prepared, 24 hours or so. But yeah, I'm happy to do a talk. I'm happy to be here, and I'm happy I got the chance. It's not the first time I speak in the Turku CNCF Meetup, actually. I did a talk, I think it's almost exactly 4 years ago, 2019. Yeah, and I have a nice bridge over to your talk later, Lucas, because I talked about RBAC at that time. Now it's time to move on. But
I do it partly because of this.
Nice, cool. All right, but yeah, my name is Lennart Jern. I work for Ericsson on a lot of open source stuff, among them Cluster API. That's well, most of what we do has something to do with the Cluster API. Anton already gave a good introduction to operators, like also in general, so that's nice. I don't have to explain all these details. But as a background, for those who doesn't know, Cluster API, the same kind of stuff you saw Anton do with Postgres clusters, you do that, but with Kubernetes clusters. So you write a YAML file where you define what kind of cluster you want, you apply that in the first cluster you have, and suddenly you have more clusters. So that's the idea about Cluster API. And I will talk today about scalability. So how many clusters you can manage and how big. And then introduce the in-memory provider. We will see what that is soon. Feel free to stop me and ask questions. That's always welcome. Like I said, this is not so well prepared, so I may have skipped over things or forgot to mention them. I see. I wonder what that is about. No idea. Now it went away. All right, so here's the task. Well, the team I work with at Ericsson, we got the task to ensure that we get some kind of scalability goals met in Cluster API and the Metal Cube provider for Cluster API that we work with. So Cluster API is very generic. You just define your cluster. Then underneath you have multiple providers to choose from. You can have a provider for AWS, for Google Cloud, for, in our case, Metal Cube, which is bare metal. You provision bare metal servers and create clusters out of them. So the goal was to reach a scale of 1,000 clusters-ish for the full stack then. Copy is Cluster API. Metal Cube is the provider underneath that we need. So we need, of course, this across the whole stack needs to be able to handle this. The first thought then is, okay, how do we do this? 1,000 clusters, that sounds very expensive. We are talking bare metal hardware somewhere we don't, like Ericsson may have that, but our team does not have that in a closet anywhere. So this can get really expensive, and we don't have that kind of hardware. Can we do it some other way? Quickly we realized that the bare metal operator, which is part of this stack, it has a test mode. So basically you cut out the lowest part of the stack and you just pretend that, yeah, I'm provisioning a server, it's going great, now it's ready, go. But nothing really happened. So that's great, we start there, we cut off the lowest part of the stack and we start to do this. Well then, Cluster API will not be completely convinced by that because it will expect that some workload cluster shows up at some point and will be able to see them and interact with them. So we need to fake things there also, if this is the approach we choose. So we started doing that, thinking about what can we do here, and doing it in a very iterative way. So just pick the first issue, the biggest issue, and try to fix that, then move on to the next one. We ended up with something like this. Step one, we can run an API server. That's one part in a Kubernetes cluster. We can run the API server plus etcd for data storage. We skip all the rest. So we really trimmed down a Kubernetes cluster to like the bare minimum. It's not even functioning. It's just the API server and data store. That works. We can use the certificates that Cluster API expects to see in this cluster. Since there is nothing else, we can just put whatever we want in this data store. Any objects that Cluster API expects to see there, we just put them there, and Cluster API will be very happy. Great. But we do that one time, we get one cluster. And we do it one more time, and we get one more cluster. And these things are pretty heavy. The API server, unfortunately, eats quite a lot of memory and CPU cycles. So it's not the best for reaching this scale. We can get some part of the way. So step two, we try thinking about how can we do this more efficiently. Can we share one API server, one etcd between many clusters and pretend that it's multiple? It works so and so. For etcd, you can definitely do it. You can run etcd in a multi-tenant way and share it between multiple clusters. But for the API server, it turns out that cluster APIs, like the controllers in cluster API, they are not really fooled by this. If they see more nodes when they talk to this API server, well, they will be suspicious about why are they there. They don't have, like, yeah, you get some weird state this way. So then we went to the third step, distribute and run remotely. So, okay, it's heavy to run one API server for each cluster, but let's say you spread this out. So let's say I create 10 pretty big VMs. That's totally doable. In each of those VMs, I can maybe cram in 100 API servers. That's still doable. They eat a lot of resources, but 100 is not so much. 1,000 is a lot, but put 100 in one VM and then do that 10 times over, and you actually get to 1,000. So that's what we did, and we managed to get to 1,000 clusters this way. This is sort of the backstory now to how we get to the in-memory provider. This is what we were working on the Ericsson side. At the same time, the Cluster API community, we reported everything to them, all the issues we had. We got a lot of help from them in each step here, sorry. And they were now at the same time starting to think about other ways to do this more efficiently. So keep that in mind when we go forward here. Yeah, here, bright orange slide about collaboration and help from maintainers, because we could not have done this without them. Already at step one there, when we just spin up one cluster and started using that, already there we started seeing issues. And already there, I reported an issue with copy saying, hey, I tried to scale and I hit issues. Immediately they could help me with, there was some flag I did not know about for parallelism. They had ideas for how to evolve this test environment. So yeah, this is definitely the way to go. Work with the upstream developers, the maintainers of the projects that you use. Myself, I'm a maintainer of the MetalCube project, so there I could do a lot of stuff myself. For example, on the bare metal operator, we had to fix a few things, but that's my area of expertise, so that I can do. Then for Cluster API, I reached out to the maintainers there and asked for help. And yeah, they even fixed performance issues and bugs that we found while doing this. Then we have some concrete results here. Initially, stopped at 300 due to concurrency and test env issues. So that was when I reported the first issue. We reached 300 clusters. And they told me that, hey, have you thought about using this flag that allows the controller to process more clusters at the same time? Oh, nice. That I had not. I took that and we could move to 600. Then we hit rate limits, which was not configurable in Cluster API at the time. There is a sort of framework for building these operators. It has certain defaults, and basically all operators that have been built this way, they have the same defaults, and that's some rate limits that when the operator tries to reach out to the Kubernetes API to check on things and update things, it will just block itself. It's not a rate limit in the Kubernetes, on the Kubernetes side. It's the controller itself blocking, because that's quite nice to do instead of bashing out 1,000 requests in one go. You hold back a little while, so you spread them out a bit better. But when you really want to scale, you need to adjust these things. So that's one thing. Yeah.
It's a safety mechanism to not DOS the API server.
Yeah. And nobody had needed to change these things in the Cluster API so far, so there was nothing to change. Like we couldn't change some option anywhere. I had to literally go into the code and change the hard-coded value, and then I saw that it worked. So this is one thing we had to do. Once we got that far, so now we are about 600 clusters. We really hit. There is a nice story about the 600. That's a special number. The issues that you find when you do these kind of things is quite. They are quite strange. Like, things work, but they don't work fast enough. So what do you report? Like, it's slow. Yeah, but you created hundreds of clusters. Yeah, but it suddenly became slow just when I hit 600 clusters. What's up with that? It's like, okay, you start thinking 600, that's very specific. Like, you have 60 seconds every minute. Okay, 600 clusters. Okay. The controller seemed to check every 10 minutes. It checks all the clusters, and suddenly you have some kind of like 600 clusters, you need to check them every 10 minutes. There is 60 seconds there. Like you find these correlations, and you realize that, okay, there's a rate limit, and you hit it right when you get to more than 1 cluster per second or something like this, which is not so weird, but it's hard to find these things. So once we figured that out, we fixed the rate limits, then we hit the next issue, which is just performance of the one of the controllers. The control plane controller, it was it was eating a lot of CPU, like completely out of any kind of limits compared to all the other controllers, and that's quite strange. Like, what was it doing? It's not doing a lot after you create the clusters. It turns out it's actually doing quite a lot, because it was stupidly enough generating credentials every time. Actually, every time it needed to go check on one of these clusters, it generated 4 times credentials to check 4 different things. And generating one of these was already quite a heavy thing, because you need to generate like private keys. And it was doing that 4 times for each cluster that it was checking every time it was doing it. So yeah, we managed to get 80% reduction in CPU usage just by caching that instead. And that's not something I figured out. Like I figured out that what it was doing, I had no idea how to fix it. But the next day, one of the maintainers had a fix for it. So I just reported that, hey, why is it doing it? What can we do? Sorry. And this is then the nice result from that. The first graph here shows, or well, both show the same stuff, but before and after. So it's the time it takes to create a cluster. So you can see it goes up and up and up the more clusters you create. But then after implementing those fixes, you basically have a constant line. It doesn't take more time to create the last cluster than it took for the first cluster. And the blue is just like the number of clusters, so it just goes straight up. That is a good question, and I actually don't know. It may have been some kind of startup, like applying, starting to do it too quickly before everything settled or something like. Yeah. It's actually not even. It's actually not even my graphs. This was another person doing the test, so I'm not completely sure what scenario it was.
The classic if clusters, amount of clusters under 15, then it's 20.
Yeah. Yeah. Okay. This one is a bit hard to see. The point here is to show the CPU usage. This is the CPU usage for the this controller, the control plane controller. Now it looks like they are on the same level, so you need to check the scale here. This one is 100, 200, 300, and this one is 20, 40, 60. So you see the change. But yeah, now it looks like no difference at all until you check the scale. Should have put them in the same, like in the same graph. But then you don't get the before and after. So, like I said, while we were doing this, our simple way, just put more VMs and distribute the load. The people in Cluster API, they were thinking about how to do this in a smarter way, specifically for Cluster API then. This will not, like our test really tested also the metal cube provider, not the very lowest part that was doing the actual provisioning, but all the way down there, just above it. So for Cluster API, you can skip some of this and be happy still and test a lot like a pro. So they did the in-memory provider, and we will take a look at what this really is. So I explained that we can spin up a Kubernetes API server. We can put stuff in there that we want. Fine, but it still eats a lot of resources. And we don't really need that full API server with everything that comes with it. So what they did is, and this is Fabrizio Pandini, I think, who implemented most of it. I met him at, yeah, he was very involved in this. He was the one that fixed the CPU usage after I reported it, and this is like the inspiration from what we did here is what he took to make the in-memory provider. It does the same thing, but just skip everything that is not necessary. So, okay, we need some kind of server, and it needs to answer to some specific requests that comes from the Cluster API. Like Cluster API controllers, they will reach out and check that what nodes are there. Okay, so we need that endpoint. It will also check a few pods that are part of the control plane. We need that endpoint. And that's about it. All the rest you can skip. So that's what they did. They implemented this kind of controller as an infrastructure provider. What that means is that you can create an in-memory cluster. So the same way we would do with MetalCube, we would create a MetalCube cluster. So that's a specific implementation of the cluster that is like represented by Cluster API. This cluster, the in-memory cluster, the only thing it does is it's just represented in this in-memory controller by an API endpoint that answers exactly to the calls that Cluster API will reach out and check. That's it. So it's super efficient. It doesn't create any VMs or spin up any containers or anything. It just opens a port that Cluster API can check and find what it wants. So that's a perfect test for Cluster API, and I will show a recording. Don't worry, I will... What? No, you did not. Come on, connect back. But I have this one on. Why is it not connected? Okay. Demo gods or something. So I will show this one. I can do a live demo a bit later. Let's see if this works. It's probably a bit small. I'm not sure if this is possible to zoom somehow. Probably not. Well, you will have to live with it. The only thing I do here is I just quickly create a few clusters. You will see that it goes really fast. Creates all the clusters. We can see them become ready after a little while. So I put a watch up here for the machines, and down there for KCP is the KubeADM control plane. So it watches for control planes and for machines. Now the cool part here, because they implemented this as a provider, you also get a machine template, and you can put all kinds of config in there that you make up. So they were clever enough to put in timing there, because what else would you do? This is all fake. So you can literally configure how long should it take to create this cluster to get some kind of realistic load, because it's not normal that it takes 0.2 seconds to create a machine. It should take maybe 10 seconds. And even you get this kind of jitter, so not all of them become ready at the same exact time. You put there, it should take 10 seconds, and then it's like times plus minus 0.2 or something like that. So you see that it behaves sort of in a realistic way. This is all just on my laptop running, like, I don't know, this was 20 clusters, so it's not a huge deal, but compared to running actual clusters, it's a big deal. I could not run, well, maybe 100 Docker clusters I could possibly, but with this I can run 1,000 clusters if I want on the laptop. All right, so back to this one. Here's, yeah.
So how did PostgreSQL then implement? Did you use like the Kubernetes API sort of framework?
Hard question. I have not looked that closely at the code. I don't think so.
Because there's kind of multiple levels of how sophisticated an API server you can have.
Yeah.
Multiple repos of kind of the minimum one, and then a little bit more and a little bit more. So
Yeah. This is very minimal. It just answers to, like, you can see the list of endpoints and commands that it will respond to, all there in one file. So yeah, I put a list here. Just it's an infrastructure provider that's the same like you would do any kind of cloud or whatever you need to support here. So that may sound a bit strange. That why do you do it like this? But it's because that will then give Cluster API a realistic way to work with it. It always works with an infrastructure provider. So then if you implement this as an infrastructure provider, everything will look just as it would for real for Cluster API. So these endpoints then that are created, how would you do that? Well, we have the controller for the in-memory provider. It just opens another port for each cluster that you create. It opens one port, and then you increment the port number one step, and then you create the next one. So you just listen for, yeah, if you create 1,000 clusters, it will listen on 1,000 ports for each of those clusters. And each machine, so Cluster API will create one machine that will get one in-memory machine, which the in-memory provider will pick up and say, okay, I will create a node object for this in this API. So it will then answer to that when Cluster API checks it. And yeah, this is fully operational from Cluster API's point of view. All the calls are implemented and everything looks just like a real cluster. But if you try to get the kube config for that workload cluster and you do kubectl get something pod o-yaml, it will not work. I can tell you, because it does not know how to respond to those things. It can respond to the health endpoint. I think that's like the best thing you can curl, at least. So how do you get started with this? Is this visible? Yeah. So here you can see. I said you can get the timings in this template. So you get an in-memory machine template, and here you can see like startup duration for the VM. Yeah, the VM. We don't create a VM, but for any other provider, there would be creating a VM. Then once that is done, after 30 seconds, give or take, then the node would appear in the API 10 seconds later, maybe. The API server would take 10 seconds. So you see, you can configure all of these things there, whatever values you want. What kind of time do I have? 5 more minutes. Okay. Let's do quick. I think I have just, yeah. The final piece is just this, that the work goes on. Cluster API folks are not done. They have a huge issue with how they want to automate this, add tests in their like end-to-end tests where they check this to make sure that there are no regressions. We work in Ericsson to check also the lower part of the stack. And there was a KubeCon deep dive that you can check for more details on what they did. They did more than what I have shown today. So check that. They even mentioned my name. I'm very happy about that. So yeah, if we have a few more minutes, I will then I will then show. I have a small playground repository where I can show you how this works. So let's see if we. No, let's see like that. Is this somewhat visible? Yeah, okay. Kind create cluster. If you have not used Kind before or Kubernetes at all, Kind it stands for Kubernetes in Docker. This is a way to create a Kubernetes cluster in Docker. So it's a fast way to get something to play with. It's done. I got a cluster. What else? Then I use this cluster CTL command. That's for Cluster API. Everybody has these CTLs nowadays. So I will initialize cluster API with the in-memory provider. Like you see the infrastructure in memory there. You can put infrastructure Docker or MetalCube or OpenStack or what have you. Okay, it will install cert manager first, and then those the providers. After that, I will get the in-memory cluster class from the cluster API repo. So that is just a collection of manifests like with some good defaults for creating these machines, like the one I showed before with the timings. It's maybe a bit unnecessarily long wait, those 30 seconds, but I did not change them. Then from that I will generate a cluster. So let's see, is that one done? Yeah, good. So now I copied 2 commands there, so I apply that cluster class and then I generate a cluster that I put in a file here, in memory cluster. Sorry. Then I can apply that to get one cluster. Yeah, sure. That's a good point. In memory cluster, there it is. So it I use topology, which means I applied the cluster class before, so almost everything is in there, like all the relevant stuff. So in here it's very minimal. I just say I want one replica of the control plane, machine deployment from the class default worker, and 0 replicas. I just want a single node cluster here. You can then get the cluster. You can get machine. It's not quite there yet. It's provisioned, but you don't see a node name yet. We can get the control plane. There is one unavailable still, but it's coming there. Let's see if we wait. Now the node name is there, and probably this one. Yeah, API server available, and it's initialized, everything working. That was 1. Okay, let's create 100. This is like, I love how easy they made this. Now we create 100 clusters, just like. Yeah. Let's see if we can. Yeah. So we have the one that we created, and then you see the other ones are provisioning. Should take about 30 seconds before, like you see the age there, before they start to get some kind of, like, then the VM is up or how it was, then 10 seconds later you get the node or something like that. So now you see the provider ID starts to appear after those 30 seconds. Then eventually the node names. But there was API server also needs to appear 10 seconds or something after that. And that's it. You can't really do anything with these clusters. It's just fake. But yeah, it's a good stress test for cluster API and these controllers. And look, my laptop is not breaking a sweat even. It would have without that CPU reduction bug fix. Oof, it was crazy. That maybe I want to show that one thing. This is the issue for it. It's a good idea sometimes to read these issues and see what issues do maintainers react to and how, because you can learn how to create really good issues that way. So I explained exactly the test I set up so they could reproduce it. These are the steps, 3-4 steps. I just created 10 clusters for this, 10 clusters with Docker containers. I gathered some profiling data. I showed them that, this is the control plane provider, controller. This is all the others. Like there is something wrong. And then from the profiling data, you could see what it was doing. This is too small to read, but it's something like certificate. No, it's get workload cluster, and all these down here is something about generate private key something something. 1, 2, 3, 4 times.
Profiling is really nice in that.
Yeah, yeah. This image or one just like it was even in the KubeCon talk then, where they explain it. Yeah, the 4 connections and how they then fixed it. All right, I think that's it for me. If you have any questions, feel free to ask. I will just, maybe this one is easier to, yeah. Otherwise, I say thank you for your time. Yeah. Yeah, so this is just time that the in-memory provider will wait. Like, yeah, exactly. So when the in-memory provider sees the in-memory machine, it will be created from this template. So it will see that, okay, it should take 30 seconds before the VM appears. So then it waits 30 seconds and then it appears. Yeah. Thank you.
Okay. Oh, you have the remote control there. Okay. Yeah. All of this great technology. Yeah, I mean, it worked as expected. Okay. Yeah, great. Let's talk about RBAC, role-based access control, authorization, all that kind of stuff. Before I introduce myself, so I'm Lucas. Hi, nice to meet you. I'm a CNCF Ambassador and kind of Kubernetes maintainer, doing some, being quite heavily involved in the cluster API, kubeADM things, and all kinds of other things in the Kubernetes space. But I'm officially I'm still studying, and most of these things I actually did before university. But at the moment, I'm looking into generic control planes. So you've seen 2 great talks today about how to use Kubernetes for stuff that really has nothing with containers to do, right? And this is the most, in my opinion, exciting space to kind of work in at the moment. I'm thinking about how we can get to a place where Kubernetes is really it's really 2 projects. One which is the API runtime, and that's, in my opinion, the most innovative part. And then the container is just one of the implementations on top of that. And in order to do that, we need some new tools and stuff. But yeah, the 2 latest years I've been doing stuff in the student union for the automation students. Anyways, so this is a talk I delivered in Chicago a couple weeks back together with Jonathan Whittaker. So yeah, just in time for KubeCon, you might have heard of conference-driven development. So that's what I also, as many other people do. You can find all of the code and steps to reproduce here in this repository. So let's dive into new ways of doing authorization, or relatively new ways, at least. We'll talk about OpenFGA, one of the CNCF projects in the sandbox phase. Then we'll talk about what is authorization in the context of Kubernetes. Then I will re-implement the authorizers. There are 2 main authorizers in all default Kubernetes clusters. One that is called the RBAC authorizer, which does role-based access control, and one which is called the node authorizer, which lets the node only see such things that the node should see. So for example, a node shouldn't see a secret or pods or something that doesn't belong to itself. Because then you would be able, an attacker would just be able to pawn one node, and then they could see everything in the cluster. We don't want that. So those 2 I re-implement using this other model, and then I'll also see if the demo guards are with me today, and then talk about some next steps. So OpenFGA is one of the implementations of the Google Zanzibar paper, which was released in 2019. So Google Zanzibar is a way of doing, is what Google uses for all of their access control. They have one single big graph database, essentially, which all of YouTube, Drive, all of these kind of things talk to every time they want to ask, is user X does user X have a relation with object, whatever, YouTube video, foo, as read or view or something like that. And what is nice about the paper is you read it, the P95, so 95% of the requests, they return in less than 10 milliseconds, which is quite a feat for having millions and millions of requests per second. So OpenFGA, every time Google, writes a white paper, then open source projects just bloom. So OpenFGA is one of the projects. There are some other good ones as well in the open, such as SpiceDB. And together with the maintainer of OpenFGA, which is a CNCF project, then I made this talk. Jonathan, which was listed here. So, without further ado, let's, and yeah, there is an open source community, join that. So what is the Zanzibar model all about? First, you specify, all of the things we've seen today so far are declarative. So you tell what is the end state of something. You tell what is the state you want to be in. And here we talk not about infrastructure states, but about authorization states. So what is your model of authorization? You define that, for example, I have users in my application. Users can view folders, and folders have documents. That is, quite a fair model. And then further, I can say that if a user users can view the folders and document, and if they can view the folder, they can view the document, etc. Then I say that I get some data into the graph. Say I have one thing, Lucas can view folders, or folder customers, and customers has secret. Then I ask this service, which is a Go, written in Go, and such many other cloud-native projects, can Lucas view document secret? Yes. What folders can Lucas view? Or what documents can user Lucas view? Now we can actually start getting some data out of this graph. There's lots of good tooling in this ecosystem. All of these kind of are Zanzibar inspired. Looks something like that. And the data model is really nice. We'll get into that in a bit. How to deploy this OpenFGA project? You can deploy it as a kind of standalone service. You can write it just in memory in your Go application, even like we kind of saw here. Or you can have like normal Postgres or MySQL behind it, and you access it through gRPC or HTTP. So let's look at the data model. We have nodes in the graph. All the nodes have some type, so node document, node type user, something like that. And then we have directed edges between them. So here we have a possible relation between the user type and the document type. So read and delete, for example. Okay, fair enough. But this is just a possible relation. I kind of had dotted here because it doesn't exist in the graph. But then when we have a tuple, then we have a concrete one of these. So it says that this node and this source node, this target node, have a relation as read. So for example, if I now would query the graph, then I can say that user Lucas has a read relation with document secret, but it does not have a delete relation. So these are different. So now, how to emulate RBAC with this model? Well, we now want this resource pods, for example. Okay, that is the kind of the target node we're trying to access. We're trying to access it as get. And now, when we get an API request like this, we will ask this check request to the graph and ask it, is this node and this node related as get? Okay, so let's see. Well, surely there is, from resource pods, there surely needs to be, if it has no get relations at all, then surely it's not. But here is actually a get relation. Let's see where it leads. Well, anyone that has is an assignee of the role getter, it has this relation. Okay, so let's see who is an assignee of the role, this role. Well, anyone that is an assignee of the role binding is also an assignee as get of this role, and then also recursively there. And actually, Lucas is one of these assignees. So now we have a path in the graph all the way to Lucas. It's allowed through. Same thing for delete. Now I can, well, it's kind of repetitive almost. Here, it goes there. Anyone that is an assignee of the role, then this role binding is assignee of the role, and I'm an assignee of that. So that's a kind of straightforward example. How would we write that? This is a domain-specific language. There are other out there as well, but it's kind of, the idea is here we say that, okay, user is related to role bindings through the relation assignee. Then a role binding, or any role binding assignee is also an assignee, can be assignee of role. And then any resource can have a get relation with any role assignee. So that's a kind of definition of that schema, right? So that is kind of all the definitions in the graph. And I think when we start thinking about this, I think it's quite amazing that with only these definitions, like two ways of defining, direct assignment or kind of anyone with the relation to this, that type of assignment, Google can do all of their authorization. It's quite cool. They do have one more thing though, that although that's the only thing that's stored in the database, you have kind of rewrites on how to read these relations. So at the evaluation time, you can kind of do some rewrites and do some evaluation tricks. So one of the things is called computer user sets. It doesn't say really much, but it's a very simple concept. If you can edit the document, then you can view the document. This is kind of a fairly logical thing. So like if you have one certain relation edit, then you also have this view. And this is here like view, then or can edit. Fair enough. Then inheritance, so if you can, this is what I talked about in the beginning, if you can view the folder, and the folder and the document has a parent relation or something, then we can traverse it. So we can say that I can edit this if also the user can edit the parent. Then they can it's recursive, flows down. And then it's just set operation, union, exclusion, intersection. That's all. That's 5 kind of elementary graph operations, and with that you can do, or at least Google manages to do all of their authorization. I highly recommend reading the paper. It's nice. So let's look at Kubernetes. Kubernetes is a unit, or it's extensible that we've seen a lot today, but it's also uniform. Or what makes it possible to be so extensible is because it's uniform. And here you can see how it's uniform. So in order to get something, all of the Kubernetes objects have an API group, an API version, and an API kind, or an object kind. So if we have a deployment or a network policy or a pod or something like that, that's the kind, all of them exist in different API groups. So in order to ask for something, then you say APIs, we say the API group, the API version, the kind, and then the name. And then just very standard HTTP verbs. So this is really as you would expect. Then list all of them, specify no, name, then watch. We've also seen that a couple times today. Put for update, patch, delete. Yeah. That's really all of it. So when such a request is issued to the API server, we always have then, we have a user information. We know the name, the groups, and the UID. Maybe some extra things as well. That comes from the authentication step. So the authentication step is also pluggable. Everything in Kubernetes is pluggable. So you can add any authenticator to it, which takes something, a token or whatever, and gives us these 3 things. You can do OIDC, you can do certificates, all kind of stuff, webhooks. Maybe the most common is certificates and OIDC. So they give us this. Then we always have an API group, we always have a kind of resource. Then we always have a verb as well, like the operation we're doing. Sometimes we have a namespace, sometimes we have a name. What is the output of the authorization phase? Well, we have either it's allowed, in which the kind of checking short circuits and gives an allow response, or we have no opinion, which you can say that, well, I don't know, I don't have context for this specific request, so I can't say either should it be allowed or not. Or then I can say deny, and then it short circuits and just says like, okay, this should not happen. So for example, if you have no role-based access control rule, then it will not return deny, it will actually return a no opinion, because it's just not something it has information of. So you can actually add, when there is this chain of all the authorizers in Kubernetes, you can add another one which then allows something that RBAC wouldn't. And in fact, the node authorizer is a thing that is placed first in the chain, actually denies anything that comes for a node that is not something it should have access to. So even though you would add something that node foo is able to get this other pod, it would still be denied because the RBAC, so the node authorizer denies it in the beginning. So in Kubernetes, if you have done RBAC in Kubernetes, it looks something like this. You start by defining a role, cluster role if it's for any namespace, then a role if it's for a specific namespace. Namespaces are essentially just a way to segregate kind of group similar things in the cluster, similar objects in the cluster. So you would say that this team 1 can do anything in this namespace, and we don't care what happens there, but at least they don't touch the team 2's namespace. Fair enough. So, but now for simplicity, we look at the cluster level stuff. So we say that anyone with this role can get list watch deployments in the apps, or app deployments. Then they can also update the status of these deployments. Okay. And then we bind, with the role binding, we bind these two together. There can only be one binding per, one cluster role per role binding. And then we can have a number of subjects. So we can say that, well, user Lucas is bound to this, but also anyone in the team members group is bound to this. Okay, so now I've made the connections. How does this look? How do we model this? How do we kind of flatten this into a graph? Okay, let's see. So we have resource, apps, deployments. We need to have both of these to kind of fully qualify them. And here we have a cluster role node. We call it reconcile deployment, same thing as here. And so anyone that is an assignee of this should be able to get, list, watch the resource app deployments. That is what we're saying here with this. And then also deployment status, anyone with this that's assigned to this should also be able to update. So this is kind of a map. You can think of this as the map from this object into this graph. So only this becomes this when we kind of flatten it. Then for the cluster role binding, it turns out to become these objects. So we say that we always have one kind of core node, and this is a core node, deployment users. Anyone that is assignee of this is also an assignee now of the cluster role. So this turns into this, and then this turns into this. So user Lucas is an assignee of this deployment users, but also group members is an assignee of this. So now we have made all the way, so we can see that user Lucas can get apps deployments. Any questions so far?
Are there any tools for this?
This is what I made, like a month back.
Yeah, so like you can take your YAML and then like give it to a tool that generates that.
Yeah, so I made a declarative kind of language, or I don't know, like it. For now, it's in code. It's a generic model. It's in code at the moment, but I'm gonna turn it into Cell. So like a common expression language, also I think from Google, which is a non-Turing complete language, which allows you to, for example, JSON or normal object input, to run some small function on that. So like some functional mapping, for example, which can do this, yes. Yes?
Can we skip one of the cluster role or cluster role binding? It seems sort of...
So yeah, you're asking a really good question. Can we skip one of these? And indeed, in the beginning, I did not have two of them. But there is a really interesting thing, and I will show this in the demo. We cannot if we want to reconcile. So when I see, so initially on this first time when I put this into graph, it's all okay. But what if I now get a new, everything shuts down, I don't have any cache. Then I start up again. Then I see a cluster role which is not the same as this. Say it would wipe this all out, or say that the list would be removed here. Now, the list is still in the database. Because now these ones are authoritative. These are the desired states of the truth. This graph is just a mapping, like projection of that data, so that we can query it easier. But how do I know if I should remove that I should remove exactly this list relation? I need to query everything that has a relation to this one. So I need to have a clearly defined ownership of every edge in the graph. So that's why this one is owned by this one. This one is owned by this one. But these green ones are a product of this one. So by having a specific ownership, and this could be solved in other ways, yes. So if we had some metadata on each of these edges here, we can also specify an owner of the edge, such that then we can reconcile and know from where it comes. But for now, there is no other kind of metadata of the edge. It's only source node, target node, and the relation. So then if we start reconciling, we cannot know that, for example, if these would be the same, we cannot know that should some of these be removed, because we don't know from which side. In this case, maybe it would work, but kind of in general, the problem becomes, I already faced this problem with some of these things. So but it's a very interesting kind of way to think about it, because we need to be resilient to perturbations over time. So yes, so I'm proposing this this type of controller. So it processes API objects. It can be any API object, again. Like it can be Postgres things. It can be bare metal, whatever, metal tree kind of CRDs. That someone should see a machine deployment, should see a machine set, then machine. And if I have kind of some specific access control to the parent one, then I should be able to traverse to the other things and so on and so forth, or the other way. So, but any API object, and then RBAC definitions are some of these API objects, but it can be any. And then flatten and project this into these edges and nodes in the graph through something that is, it can be a function, but still it's declarative. So this function maps it down using cells and then writes these to the backing data store. In this case being OpenFGA, CNCF product. So let's see how this now works in practice. So user Lucas, I get this get apps team1 in the namespace team1 deployments and my deployment. Okay, so now I target the resource instance, which has API group, API kind, and the name. And I should be able to get a get relation to this. So how do I do that? Well, if I have a cluster role which is called view all apps, that says that I can get any resource in the apps API group, then I would have something like this. But still I'm not bound to it, so there's no connection. So that's not enough. I also need to be an assignee of this. And now you see now I skipped that, that extra node in this visualization. But yes, I'm an assignee of that. Now I should be connected now, because I'm able to view any kind of resource with any name in this apps. But actually, I can't make it through, because I don't know in the graph, how do I know all of the names that could ever exist? But that's why we have contextual tuples. So we can add context to this specific check request. These are never serialized in the graph, but because I know exactly what I'm looking for here, I can say that, well, I'm looking for a deployment, and surely if this user managed to get bound to this apps.star, then they are surely bound to apps deployment, which I'm looking for. And if they manage to get to apps deployment then and can view any deployment, then for sure they can view this specific deployment. So that's a kind of really nice feature of OpenFGA and the other graph engines. I was first really confused, well, like, why did they add this context thing? But once I started using it, it makes a lot of sense. And then I can say the same thing for a kind of, imagine, although I wouldn't have this, I can have another path in this graph. So I say, in team 1, I have a role. So team 1 is in the, team 1 view deploys is in the team 1 namespace. And then I can add a kind of assignment here to myself. But actually now we have a problem with this graph, because if it would only be like this, then although this role should only apply in the team 1 namespace, now it applies to any namespace. So that's why I need to add a contextual. I need to tell the graph also where am I operating when I'm operating in the namespace team 1. And only if there's a path here and I'm bound in that namespace, then I can access it. Only if so if I would change this to request team 2, then I would be operates in team 2 and there would be no kind of two paths in the graph to this end. Only then I can get there, and then I can kind of continue traversing. So it's quite interesting, like quite a nice, and you see how extensible this model is. Now this is just for RBAC. There's many other things we could kind of emulate a model with this. Yes, so graph relations. What are the other things? This is RBAC. Now here, for example, if we had node A and node B, I already touched on this. Pod sees a service account. They see some persistent volumes, but and this other deployment sees some secret. Well, still, because node A doesn't run foo, the deployment foo, they should not be able to see this secret. This one surely should, because they need to provide that container the secret. But making sure that there's no connection between this is another job of the node authorizer. But I want to extend this to any generic control plane and any kind of authorization domain for other things as well. So what do I do? This is one case. So like for machine deployment or any deployment or any something like that, they have this kind of natural graph folder, kind of graph structure. So now we can start adding rules to like project this into the graph database and say that this is how I want to traverse this graph for authorization. Way beyond. So this is what I did. It's, as with most software projects, it takes half a year to think about it, and then it takes 3 weeks to actually write. So I have re-implemented the existing authorizers in Kubernetes. I'm supporting the existing APIs, and I use this with a webhook. So the API server actually calls out to a webhook, which is a custom server of mine, which then evaluates all of this kind of stuff, talks to OpenFGA. And this lets us prototype some more fine-grained mechanisms. So this is how it looks, API server. Synchronously calls out to my webhook, which is a server, like normal HTTP server. That does a synchronous check to OpenFGA, which has all of the graph data. I think now I store it in memory, but I could store it in a database as well. And then asynchronously, there's this controller which reads the Kubernetes objects that are kind of, that I specify it using a CRD that it should be read. And then it projects this into the tuples, and then writes that to the database. Also, because we have this kind of ownership of the tuples, it removes the tuples, the edges in the graph that shouldn't be there. So we'll hope that demo guards are with me. Okay, so here is my repo. I did a Docker compose up. Here is all kinds of things. There's etcd running. I'm going to show that. So we have an etcd with the data store of Kubernetes, running that locally. Then we have a kube API server. I tell it to authorize. Is it big enough? I can make it a little bit bigger. Authorization mode webhook, and I specify a file where is the webhook going to be. Then I run OpenFGA on port 8080. Then I run my own project and give some files. So here we say that call out to this authorizer 9443/authorize, give some search and stuff. And then I have a queueconfig just for me to talk to the API server. Yeah, and then I have actually 3 users. I have one admin user that can do anything, a normal user that I will showcase RBAC with, and one node user to show them those things. And I have defined these users using a very simple mechanism. Just tell Kubernetes that if you see this UID, then it's this user. But OID is of course, in a real product. So let's open a new terminal.
It's the only authorizer in this.
Yeah, because so normally in any normal Kubernetes project you would have authorization node mode comma RBAC. Yeah. So there's no cheating here. Yes. So let's see. Actually, I'll try to do this and see if it goes. So I will use this. then I will say I'm going to use the normal user context. Oops. Okay, good. And now when I copy paste this, yeah, it is. It's not working. So it doesn't have type ports. Let's see. I think it's running, yeah. Anyways, it's denied. Let's see if it now works. Yep. So now I create a cluster role that says view pods, so I can get, list, watch pods. And then here to the side, we see that now it's a little bit hard from the OpenFGA logs, but here is core resource pods relation get user cluster role view pods assignee. And then same for list and watch. Okay, so it works. Now I switch back to the normal user to which this is applied, but I should not have any access. It should still be denied because, yeah, so forbidden because I was never bound. I created a role, but I didn't bind to it, so okay, makes sense. I go back to the admin context, which can do anything on the cluster, and then I say that cluster role view pods should be given to normal user. Okay, I created that. Oops, what did I do now? Yeah, normal user. And now I should be able to, yeah. So now I couldn't do it just a moment ago. I keep typing some PowerShell thing up. I can, yeah, this is not found yet, the pod isn't found, but still here we can see that route response get pods allowed through. Okay, so great. Now I showed that. So I wrote to the graph, I queried the graph, and it worked. Awesome. And now I will show the reconciliation so that the controller actually, okay, now I see what I did wrong. I kept using shift when I pasted. So I will remove the list and the watch verbs. So I will still have the same object, but I will only keep the get. So now this should remove two edges from the graph. I save it, I exit out, and now I see that actually writes null, deletes here, relation list between core pods and cluster role view. Same thing for watch. Those two are deleted now, those two edges. So as I can expect, I should not be able to get all of the pods anymore. That doesn't work anymore. But I can still get a specific pod. Now again, this will say pods not found, but it's still allowed. And then I can still get anything in any, like get a pod in any namespace, but I cannot watch anymore. That is not forbidden now. So that's emulating or re-implementing RBAC without the RBAC authorizer using webhook. Now I will show the node. So let's see. I switched to the node user. Oh, there's a lot of things here. So all of these, I shouldn't be able to do anything because I'm a plain node. I have no access. All of them were forbidden. Okay. It's as it should. Switch back to this context, and now I apply. Oops. Well, so what did I apply? So I applied now a node called foo node. This the same as the user. I called foo node in the tokens file. Create a service account. I create a pod, super minimal, Nginx latest, and it refers to mission critical and very secret. And this pod is bound to this node that I just created. And here is mission critical and very secrets. Okay. Now because I created this, now we can see that here actually stuff happened. So we have core secret in the default namespace, and mission critical has a relation pod to secret in to core pod default hello. So now we started getting these kind of inter-object dependent, like in the graph paths. So now if and likewise now the node is related to the pod, and the node user is related to the node. So I cannot still, I shouldn't be able to get all nodes. If you actually go and look at the Kubernetes source code, actually any node can view all nodes and any node can view all pods, but I'm a little bit more strict in my implementation. But I can get myself foo node. Okay, perfect. I shouldn't be able to get all the pods, which I can't, but I should be able to get recursively, because the user, node user, is bound to the foo node, and then that is bound to the pod hello. So I should be able to get hello, which I can. I should not be able to get all of the secrets, but I should be able to get the one that the pod hello refers to, which I'm running, which I can. And I should be able to get the other one as well. So that's, that's the demo. Works recursively, works re-implementing RBAC. So there's a shit ton to do left. But this is proof of concept to kind of experiment with these ways. This Zanzibar model is a very interesting way to map, which is a superset of ABAC, it's a superset of RBAC, it's a superset of many other kind of disciplines in your application. And the nice thing about this is that now you can start, even if this is just a projection of all of your other authoritative data, you can now start mapping in all kinds of other stuff. So you have keycloak. Okay, well, map in all of the keycloak groups and whatever. You don't need to put them in the OIDC token. The only thing Kubernetes needs to know is, okay, I have this user. Okay, is this user with this UID able to get this node somewhere here? And then you can build the kind of path in the graph exactly as you want, partly with Kubernetes data, but maybe partly with stuff that is not part of Kubernetes. So like GitHub teams, keycloak teams, all these kind of other, more or less in cloud provider, IAM, and stuff like that. You can all start projecting this into the graph and get way more extensibility than you could ever would be sensible to put into kind of custom resource definitions and our RBAC rules and generating RBAC rules. We get all of that. We also get the ability to do deny roles. For example, Kubernetes RBAC is purely additive, but now we can actually, the authorizer, you can build deny authorizer, but RBAC itself, that one authorizer is only allowed or no opinion by design, because deny rules are hard. But there's very good reasons for not having deny rules. You can easily shoot yourself in the foot with it, but having this kind of more generic framework gives an easier time to reason about it. Now I mentioned the common expression language. This was done in code. I can show the kind of how the node authorization kind of mapping looks like. So it becomes this kind of declarative-ish schema of like, okay, I define a node, the name of the node is its identifier, and then I say that I have a incoming relation from user with the name system node and its own name. So that should be able to have an incoming relation to me. And then I say that, okay, for core pod, my identifier, and this, again, now this is in code, but this could be a cell expression very easily. My identifier is p namespace and p name. and slash between those. And I have an incoming relation from core node type. The relation is called node to pod. And then the node name serves, the pspec node name serves as the identifier of the incoming connection from the node. But I also have outgoing things to core secret, and that I call pod to secret. And here I do a flat map, 2 flat maps of looping all the containers and looping all the environment variables in the container. And then from there I find that in the same namespace as the pod, there's a secret with this name. And then here I can say this kind of, so that's the definitions, and then I said that there's 2 types of definitions, and then there's there's 3 rewrites. And here I'm using a rewrite and saying that, okay, the user can get myself, like me, the pod, if they can get a node which has a node to pod relation with me. And now we can kind of start declaratively. It took me a while to kind of figure out, this is probably not the most optimal way to define declaratively on how to map this and how to evaluate this. But from this, all of the kind of other things are generated. So this could and should be a CRD. And here again, like for secret, so okay, a secret can be get if there is someone that has the get relation to someone with to a pod which has a pod to secret relation. So yeah, that's that. All kinds of other things. If you're interested in this, looks as cube RBAC authorizer. Then go to this repo, and here is on the plane to Chicago for KubeCon. I wrote 6,000 words on how this works. So if you're not sure about even after this document, presentation, then you can go and here learn all about it. Also kind of covers the important stuff on Zanzibar itself. So yes, thank you very much. Any questions? The original, yeah, so performance testing compared to the initial. I expect it to be as fast, more or less, for the in-memory use case. So the RBAC authorizer and the node authorizer actually, so the RBAC authorizer just caches all of the RBAC rules in memory, so object structs in memory, and then it loops them like one at a time. Is this allowed? Is this allowed? Is this allowed? And then, so a quite naive graph search, but surely good enough. And the node authorizer actually builds an in-memory graph of all the cluster state, also by caching all of the objects that, all of the pods, node, secret, all of those objects cache in memory, and then from there project and build an in-memory graph highly optimized for that specific use case. So I expect them to be roughly as fast as that if it would be built into the API server. So like if you would build this authorizer into the API server exactly as it is now, and also build the whole OpenFGA in-memory thing into then it would be equivalent, more extensible, but equivalent deployment mechanism. Having it actually do this kind of first API server call out to the webhook, then having the webhook call out to OpenFGA, and then first taking the decision and pipe it back is for sure slower. But that's a kind of, the idea of this is to not to kind of take into use directly as is. It's more to kind of play around with this and see where we get the benefits out of this, because this is something that I'm going to work with SIG authorization and kind of, especially for these generic control planes, where you might have a Kubernetes API server, but you have no, there's actually a good project about that. If you switch back to I can do a prop for my friend's project. Was it? I was, so this one, KCP. This is a generic control plane. It essentially is the API server, but it has removed all of the nodes, pods, like all of the stuff that is container specific, and left its only ability to extend it with generic stuff. So here, that's why I asked the Fabrizio thing, but I actually checked the code, and he made only specific like re-implementation, which is enough for that. But for generic control planes, this is more better. And then there's also this in SIG API machinery. It's also going effort to refactor the API server such that we don't need this KCP at all, but it would be a kind of one of the official Kubernetes kind of controllers or repositories. So, so for these kind of things, it becomes very interesting. Of like, okay, actually, then for most of those things, it would make sense to not have it as webhook, but build in the thing. And then the only hop is between the API server and the OpenFGA or SpiceDB, and both OpenFGA and SpiceDB have shown that they can do 100. Already they are a couple of years old, but they can do 100 billion edges in a graph and 1 million requests per second with latency. It was something like 95%, so P95 requests less than 10 milliseconds or 15 milliseconds or something like that. So it is still like, even at that scale, it needs to do crazy kind of deep searches and stuff in the graph. So most of them return within 1-2 milliseconds. So I think that in order to get, if you get all of these kind of other benefits, waiting 2 milliseconds in that kind of search graph for average of your results, yeah, it costs a little, but still a good price to pay for only one hop between your things, and then heavily extendable authorization mechanism. So yes, the kind of having these graph databases be highly optimized for this specific Zanzibar authorization use case makes them super good at that specific thing, which we can optimize them heavily with graph algorithms and stuff. And then it's just a matter of placing the API server sufficiently close so the network latency is not too bad. And then you have a very high performance extensible generic control plane for anything. Or just Kubernetes with better like more advanced authorization. So yeah, then we can avoid the roles explosion in RBAC and all of these kind of other stuff. Fun problems that everybody's getting sooner or later. Any other questions? That was a good one.
Is there a way to query the graph database? Like now if you for example, you give me a kubectl cluster, and I as a developer, I want to see what damage can I do. Like normally, like I maybe can't list namespaces, but is there a way through this that you can just query the database and ask which namespaces can I list?
Yes, so the question is there a way to see what I can do in the cluster? And Kubernetes, there's a crazy amount of engineering gone into the Kubernetes API, so it's really amazing. It also has that. So you can do kubectl. Actually, maybe I can do that, let's see. So kubectl can I, oh no, what? Get nodes. No, I can't. Foo node. Which context am I in?
Like if you don't know that foo node exists, you don't know like anything about the cluster.
Yeah. So okay. So yeah. So you can ask, can I do this specific thing, and that's called a subject access review. But you can also ask, what can I do? And that is called a rules review. So you can do both. And what I haven't implemented for this yet is the kind of list me all the things. That was one of the things I put for the future. List me all the things I can do. That is done through the reverse search called list objects in the graph. But Kubernetes supports that already. It doesn't just support it for the webhook authorizer, so that's why myself and, but it supports it for RBAC authorizer and the node, I think. So So that's why we put together, I don't know if you published it already, but put together a proposal for actually just adding that small part of like supporting it for webhooks as well. But yes, there are the official APIs. So Kubernetes. So this you get status, what all non-resource rules, what are all the resource rules you can do, verb API groups, resource, all of this kind of stuff. So then you know your blast radius, and this is meant for dashboards mostly, so that dashboards can just do one query and then they know everything they can show, and then don't kind of spend a lot of unnecessary requests on asking stuff that it can't do for that user. So yeah, but this is one of my latest projects. If you're interested in this, would find it useful, please let me know. This is came up with the idea, then wrote some proof of concept, went to talk about it, and now it's like seeking for feedback. Like should I put more time into this, or is it a dumb idea? It's between those at the moment, and then of course this is a Kubernetes community project. The special interest groups leads they are very, anyone working on the Kubernetes project is very overloaded because there are way too few maintainers, way too much to do. So as with this, what Lennart was saying as well, if you have something that you want to do, then spend a real good issue on it, or then just say that, hey, I noticed that this is not done. Here I would like to kind of come and chip in and help with these things. And this is one place where there's things we can already do to improve some of the RBAC things. I was looking actually at the label selector thing. I am pretty sure that that could be done. It just that's one of the most asked for features, right? Like I can make a rule such that I can list all secrets with label foo, or like my app foo, or something like that. I don't want to give all secrets, like all secret access, but I don't want to enumerate them by name because I don't know their names. That is one of the really common requests. That is possible to do as far as I understand and have spoken to the maintainers. It's just that by the time they were convinced that it's okay to do, it's possible to do, then there's just nobody that's done it yet. That is one of the things that, from this kind of work, then we can say, okay, let's take that one first. Or like, but it needs the amount of, person hours and eventually turn into person years of these kind of heavily tested, crazily optimized parts of the project. But yeah, thanks so much. From the side of Meetup organizer, hope to see you at the next Meetup. Also hope to see you contribute to the Meetups in terms of talking about some subject or hosting the next Meetup.